First, here's a perpendicular bisector with a compass. Center on the endpoint, make some arcs like that. Center on the other endpoint, make some more arcs. Rule up the intersection of the arcs like that. And there you have the perpendicular bisector right there. M is the midpoint. M is midpoint of AB. And of course, that's 90 degrees right there. Now, find the equation for the perpendicular bisector of the points, see, like Q at -5, 8, and R at 4, -2. Okay. First, we find the midpoint of that line segment. Midpoint we'll do capital M. And of course, it's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. The midpoint is a coordinate. And what are the two x-coordinates? The two x-coordinates are -5 and 4. So -5 plus 4 divided by 2. And the y-coordinates are 8 and -2. So 8 plus -2 divided by 2. And that will give us our midpoint of QR, which is the x-coordinate is -0.5. And the y-coordinate is 3. Okay, next we find the gradient of QR. Lowercase m, the gradient is change in y over change in x, of course. The change in y is -2 minus 8 over change in x. 4 minus -5. And down here, that gives me a -10 over 9. Okay, so my gradient is -10/9 for QR. Now, of course, perpendicular, I need to find the perpendicular, that's perpendicular sign, gradient of QR. And the perpendicular gradients, the two gradients multiply to get -1. Or I just call it the opposite reciprocal. So the perpendicular gradient is going to be the opposite reciprocal of that, which is 9 over 10. And that's the gradient we want to use, or 0.9. Finally, the equation of the perpendicular bisector. We'll use the formula y minus y1 equals m times x minus x1. Now, I use the perpendicular gradient here, and I use the midpoint here for x1, y1. So I have y minus my y-coordinate, which is 3, equals my gradient, which is, I'll use 0.9, times x minus my x-coordinate, which is -0.5, which makes it plus. Minus a negative is plus. All right. I'm going to clean this equation up a bit. I'm going to expand this 0.9 through 0.9 times x. Oops. Whoops. Went through the paper there. Sorry. 0.9x plus 0.9 times 5 is 0.45. And finally, I'm going to take that -3 and biff it over to the other side, add it to the other side. So I get y equals 0.9x plus 3.45. That is my equation for the perpendicular bisector. There's my gradient. There's my y-intercept. I'm good to go. That would be the equation of that line there. Now we'll try one more, and you can pause it so you can work it out yourself. Let's see. Write the equation of the perpendicular bisector of line segment joining point A at -5, -2 and point B at 7, -6. There's my graph, there's point A, there's point B, there's a line segment. Great. First up, of course, midpoint of segment AB, and the midpoint is the mean average of the x and the mean average of the y coordinates. And we get 1, -4 for my midpoint. Next up is the gradient of the line, a gradient of AB. Lowercase m, the gradient is change in y over change in x. So -6 minus -2 over 7 minus -5 gives me -4 over 12. Let's call that -1/3. Perpendicular gradient is the opposite reciprocal. It equals -1 divided by that gradient, of course, which is just 3. That's the gradient I'm going to use for my equation of perpendicular bisector. I do y minus negative 4, which is y plus 4, equals 3 times x minus 1. Expand the 3 through, 3x minus 3, minus the 4 from the other side, and I get 3x minus 7. Form an equation of perpendicular bisector. Midpoint would be about there. There is the line, roughly. That's the equation for that perpendicular bisector.